Okay, so members, today we are going to see how do we handle or how do we sketch curves when they are given in parametric form. Now, today I decided first to make the solution because the videos were too big, and I decided let me make the solution, then I explain the solution. So now, if you are given a curve this and this, you see that you now express it in terms of x and y. What you do, you see, you pick out on this, and this one is easier to make. Always you make x in terms of t. Now you make the subject in the equation of x, then after substitute in this equation. What we do is that if this is this, if I cross multiply, I have x times 3, I have this. Then x minus this, I have this. Now I want to make to the sum so that I can remove it from here. You know our curves are always in y and x. So after making to the subject from here, using the equation this, now I come and I substitute it in this. You know that my y is equal to this squared over this. So where there is t, now I put t, making it in terms of x. Now where there is t, I put it here, then minus 1. From there, we will simplify the cross multiply. All we are going to see the result is going to be x squared over x minus 1. And this one is that now, this equation is when the power in the numerator is strictly greater than the power in the denominator, they are going to result into slanting asymptotes, as we are going to see. So now the question was directing us that find the turning points. Now this question is directing us that in all you do, you start by getting the turning points. Because this is the quotient, I use now quotient rule. This is u, this is v. The formula is here. So my v is x minus 1. Differentiate u. When I differentiate this, I get 2x. Then minus u, which is x squared. Then differentiate, when differentiate this, we get 1 over this square, this is this. And when we simplify this, this is what we get. But you know that at turning points, always the y gets to 0. When I equate this to 0, so that x is common. When I x factorize out x, I have x into x minus 3 equal to 0. Either x is 0 or x is a 2. So these are now the x values at the turning points. For each a corresponding x value, you get the y value. So when x is 0, you start when I put here 0 over 0 minus 1, I get y as 0. When I put x is equal to 2, I'll be having 2 squared, I get a 4. Then 2 minus 1, I get a 1. So 4 divided by 1, I get a 4. Hence a point 2, 4. Then with their nature. Their nature, because they are 2, we draw 6 columns. The sign of the y-axis. So below 0, we have, I have 0, 1, then 2, then 3 up, then I have a negative 1. So below 0, on the left, there is negative 1. When I put here negative 1, you see up I have a positive, so up I be having a positive over anything up here is square. When you square anything, what you get is a positive. So always down, when you have a square, don't waste time because it's always going to be positive. So positive, positive, that's why this is positive. Now, on 0, because we got this 0 after our y-axis is 0, that's why this 0 is here. Then to the left of 0, to the right of 0, there is 1. When I put here 1, I'll be adding up a negative because it will be 1 minus 2, this is negative 1, but I'm interested in the sign. Positive divided by negative, that's why I'm having a negative. Then to the left of a 2, there is a 1. When you put 1, you have seen that we get a negative. Then 0 because we got this 2 by y-axis equal to 0. Then to the right of 2, there is 3. When you put here 3, you have 9 minus 6. So we have a positive up. Anything here is square, you shall get a positive. Positive, positive, you get positive. Now it's that up here, this one is increasing. Then it's decreasing. So it will generate as a maximum. Then this one, first one it increases, it decreases. Then after it increases, it will generate as a minimum. Then the aspects we get now in part B, find that asymptotes and hence sketch. Now, because this curve is having the power in the numerator greater than the power in the denominator, we expect a slanting asymptote. That's the ordinary case. This part should be strictly greater than the power here. So now, from here, we start by vertical. So we get the vertical asymptotes by equating the denominator to 0. When I equate this to 0, I be having x as 1. Now the slanting asymptote, now there we don't divide because that is improper. So going through long division, here you say x goes into x squared, x times this, you get x squared, then x times this, you get negative. You reduce, you get x, then you say x goes into x1, 1 times this, you get that. When you sum up, you get a positive 1. So this will be now the quotient plus the remainder over the divisor. So you see that as x tends to 0, I mean tends to positive infinity, this will be infinity over 1. So 1 over infinity will always be 0. So the whole of this will be 0. And now our y will convert into this, so our y will be equal to x plus 1. So always remember there's nothing there, sweet dot is always a line. So to get, we need also to sketch this line. I mean to put this line, we need 2 points only. To sketch a line, we need 2 points. That's why I come here and I get only the intercepts are the easiest to get. When x is 0, when I put here 0, I have y as 1. And when y is 0, x is negative 1 and take x their side. So the points are 0, 1, negative 1, 0. Of course, we also need the intercepts. When x is 0, when you put here 0, you have your y as 0, so the intercept is here. Then when y is 0, you see that x will be 0, so it's the same. Now we also need the behavior of the curve. The behavior of the curve, you say you get critical values. To get critical values, you equate the numerator to 0 and the denominator to 0. When I equate this to 0, I get x as 0. When I equate this to 0, I get x as 1. Now, so below 0, we say below 0 there is a negative 1. When I put here negative 1 up, I'm going to be having a positive over, down I have a negative. So negative, positive, I get a negative. Why? Because now I want the sign of y. For the nature, for the behavior of y, we test the curve itself. Between 0 and 1, there is 0.5. When I put here 0.5, I'm going to be having up a positive because I'm squaring it. And 0.5 minus this, I have negative 0.5. I want the sign. So negative, positive, I have a negative. Above 1, I have 2. When I put here 2, I have a positive. When I put here 2, I have a positive. So this one. So for y, these curves, you have to check. These are not inequalities, that they are both alternate. So for the curves, you check. I think you see negative, negative, positive. Now from there, we are going to sketch. I'm going to pause the video a little bit. So remember, after cleaning, I'm going to sketch, but remember they told us to get the minimum restriction. Always, if they tell you to get the turning point and they hence reduce the minimum restriction, you don't need now to go through the method. All you do from here can reduce the minimum restriction. How? You have two values of y. The y component here is that y is 0, and y component here is y is 4. So you know that the original restriction is going to be now from the smallest to biggest. So the original restriction from here you can conclude it always if you get the turning point first. You don't need to go through the method of dividing. I mean the method of original restriction. So from here, my original restriction is going to be, so the curve is not going to pass through here because you arrange them and then from the smallest to the biggest. That's how the game is going to be in one step. Now to sketch, you see my intercept. First of all, I have 0, 0. So this is 0, 0. I have here intercept at 0, 0. Then I have also turning points. I have 2, 4, 2, 4, which is here. I have it as 2, 4. But remember, this turning point is 2, 4 is minimum. So I indicate that it's minimum. Really, it's minimum. I indicate that it's minimum. Then I have a 0, 0. It shows from here that it's going to be maximum. Then I also have now the regional restriction. Y equal to 0 is this one, but we use dotted lines. Anything different from a curve, use dotted lines. Also, y is equal to 4, which is here, dotted. We only use solid line for a curve. So the curve is not passing this region. So the curve is not passing there. Then we come to a sentence, we add one red. X equaling to 1. X equaling to 1. The line passing through 1. And we name this x equaling to 1. Then what else? We add also the line, the asymptote now, the slanting asymptote we have is y equal to x plus 1. So we put it, we have 0, 1, 0, 1 here, and then negative 1, 0, which is here. So this is a line that is going, now it's also a line, an asymptote, we use dotted lines because it's an asymptote. You get your ruler and you plot it like this. So it's a line, y equal to x plus 1. It's an asymptote. Now, we said, as I told you, that this positive and the negatives mean if I'm below y, this one, positive, these are positive values of y, and these are negative values of y. Below the x-axis, below this side we have negative values of y, and up we have positive values of y. So now we start plotting. So that all I'm having, below 0, the curve y is in the negative. So below 0, this is below 0, it's in the negative. Because it has a line point here, but it's in the negative, allow me to use it's in the negative. So it's below x-axis, it's in the negative. So that's why it addresses the asymptote like this. Then between 0 and 1 is still in the negative. Between 0 and 1 still is in the negative, below x-axis. So it's in the negative. That's why it raises the asymptote. It can never touch the horizontal asymptote. Then above 1, it's in the positive. Above 1, it's in the positive. So let's see that everything here, x is above 1. So this time is in the positive. But because it has a turning point here, it's going to raise from this asymptote. Then it raises the slanting asymptote like that. So members, that's how we sketch that curve. But please always, if you get the turning points first, you can easily use the region of restriction. I wish you the best. That's how we handle these numbers.